So we'll start off with what is policy as code, why we need it, what kind of problems does it solve, and then what kind of benefits you will gain as security engineers in implementing security at scale, of course, with the advent of hybrid multi-cloud. It became pretty difficult to manage security in a uniform way. Policy as code allows you to do that. And with the help of Kubernetes and OPA and other interesting tool sets, we will be able to show a demo as well today, right? And as you know, our company's name is Practical DevSecOps. We like to keep it practical. Everything we do, it is very practical in nature. Most of you can attest to that. So we will immediately after this, once I'm done with the introduction, you will see a demo of what policy as code is and how it will help you. And then we'll go into the theory, why you should pay attention to it and whatnot. Okay, so let's go ahead. I'm Imran. I'm going to be one of the presenters for this topic called policy as code. And today we are going to cover a lot of interesting stuff. As I mentioned, we're going to talk about what is policy as code. This is an extension of security as code and why you need it in order to make your lives pretty, easy. And as per some of the research done by analysts, they say security is one of the very stressful jobs. And that's why an average age of a CISO is just 17 months in an organization. So we do recognize it's very a stressful job. So we are here to ensure or probably share some tips and tricks to make your life a bit easy. And of course, there is no, kind of a publicity in this session. These are all live and open sessions for anyone to join. These are just to ensure that we are giving back to the community from which we have learned so much. All right. With that said, I will let Maran show our demo and then we'll move forward. Maran, over to you.
All right. Okay. Just to let you guys know, my full name is Marud Maran Kumashekaran. Imran and everybody else calls me Maran in short. What I have here today, and also what we want to do today together, is to make sure that we stay true to the agenda. That is how to learn policy as code without losing our mind. Now, this is not an advanced level talk. It is a beginner level talk. It is supposed to help you assist or aid you in getting started with policy as code. We want to take a demo first approach for this webinar. So here's a little bit of introduction to our demo environment. There's a front-end application, which is built in Python Flask, which uses Azure AD as an identity provider. So this front-end application is for managing cars. So people can come into this application, list the number of cars that are in the system, and if it is a car administrator or a salesperson, they have the ability to add cars into that system. So the Python front-end application contacts the back-end APIs in order to make policy decisions and to serve the intended response. So notice that the ODZ policy allow or deny, we're going to explore policy as code through one of the most widely used tools called Open Policy Agent. And notice that the box for Open Policy Agent stays very close to the backend API, which also happens to be built in Python Flask. Because when we think about a backend, we want to think about the policies closely associated with the backend API. At the same time, the policies are decoupled from the backend APIs. So the APIs are separate and the authorization policies are separate. And then the response is served back to the front end. And in order to do that, let me get out of that mode here. So here we have a lab setup in our practical DevSecOps learning environment. The front end application and the backend application are already deployed for you in the previous steps of this exercise. So they're here. And let me just sign out this page so we get a fresh start. So what I want to get started with is to download OPA. So let's download OPA using one of its latest releases. And after OPA is downloaded, we will provide OPA, the executable OPA, with executable permissions, of course. And then what we will do is start OPA. So if I list all the files and folders in this directory, you will notice that there is a file called API authz.rego. Now that is the policy as code file written in a language called Rego, which we will be delving deep into in today's webinar. So I will clear the screen here just to make more room. And then what I'm going to do is run OPA using the command OPA run -s as an argument, which takes the policy. And then I want OPA to run on localhost port number 8000. So OPA runs successfully. With that, I'll go back to our demo application, which is integrated with Azure AD. I will start signing in. And first, I'll sign in as Imran. So after Imran signs in, he goes to Azure AD. Well, the application actually goes to Azure AD, gets an access token, which is in the form of a JSON web token. And then there's some basic rules in this application that you should know before you get started. And some of the basic authorization rules is everybody should be able to get cars. So if a person has an account in the system, that is the basic requirement for anybody to get cars. So if I try to invoke that API, I'm expecting a successful result. Well, unfortunately, there's an error there. So we got to go back and see what is wrong. So what I'll do is switch this window, open the network tab, and then try firing that request again, and then see where the error is. Okay, so apparently the requests are not getting through. So what we will do is try to stop OPA as a service here. And I want to go back to the previous step, and I want to make sure that the application is actually running. All right, so this is the backend API as a part of our demonstration that I want to make sure it's actually running. So what we will do is I'll get the no.out file. All right, so our API is successfully running, and then we will go back and try initializing running OPA with our sample policy again. So we'll try running OPA with our sample policy again, and hopefully now if you run the API, it should work without any error messages. Okay, so I'll close the debug console here. So Imran is logged in, and if you would like to know what roles Imran has in this particular identity and access management system, I'll actually show that to you about how these identities are set up in Azure AD. So we're looking at this particular user called Imran who has this role called car admin. And there's another user called Misbah who belongs to the role everyone. Now, these are the two users that we'll be using in today's demonstration. So first, we're using Imran, who happens to be a car administrator. Everybody should be able to get cars, so Imran's able to get cars. Now, what if Imran tried to delete the list of cars? Now, that's not allowed for a car administrator, so he gets a 403 forbidden. So Imran's a car administrator, so he should be able to add cars. So let's say Imran tries to add a car with the HTTP method put, that should be allowed. So Imran's able to get cars and Imran's able to add cars. So those are the two important things that we need to remember at this time. What I'll do now is log out and try logging in as a general user who is not a car administrator, who is not a manager, not a salesperson or whatever, just a general user. So when I log in as a general user called Misbah, the first case that we want to do is test to get all the cars. Everybody should be able to get cars, and we're able to get cars. So that works. Now, if Misbah tries to put cars with some car ID with a sample JSON data that is required to update the cars, this should be denied according to our policy. So we receive a 403 forbidden request. Now, imagine a scenario that this fictitious application for car management decides to go public. They want to open up this portal for everybody on the internet, which means any user that is registered to this application should be able to put cars. That is necessarily a change in organizational policy. And what we'll do now is how to implement that policy in code and without changing the front-end application and without changing the back-end application, because our policies are decoupled from all of these applications. If we go ahead and change the policy, then we should be able to implement the new organization policy that is allow everybody to be able to put cars. Now, I'm going to leave the screen as is, hit the invoke button one more time, just to demonstrate that we're still getting a 403 forbidden response. What I'll do is go back to our test environment. And as you can see here, these are logs from Open Policy Agent. As it makes the policy decisions, OPA sends out these logs that we can use to review. So let me get out of that command. And what I'll do is clear screen for more space, and I will edit our policy file called API.auth.rego. Let's not worry about what's inside these policies, because it might sound a little bit advanced, or it might sound like, oh, this is all new to me, but we will try to break that down by the end of the webinar. But if I scroll down through this policy, I notice a comment called everyone. So apparently this happens to be the place where I need to change the policy. So what I'll do is I'll start out by writing a new policy rule. And I'll say, set the value of the variable allowed. One moment, set the value of the variable allowed to true if the input dot method equal to put, because we're using a put method to put cars actually. And after that, the other thing we want to verify is input dot path is equal to cars. Now, when I say input dot path, it is the path that is present in the URL. So it's cars, comma, some car identifier there. Now, what this exactly means is, so this is the path that we're trying to match. So we're trying to match the method put, and we're trying to match the path cars/car ID 12. So we'll go back to our policy. So we've written two conditions, and the third condition is where it gets interesting, and it is what is very important. Now, as long as the user is authenticated, then the value of the user property in this policy file gets populated. So if there's a value for the user variable, then those are the three conditions that I want to match, and I will close that allow assignment statement. So essentially, what I'm mentioning in this policy is set the value of the variable allowed to true if the input method is put, and if the input path is cars/car ID, and if the input request has a user associated to it. So remember, all of these three conditions that I've typed here are ANDed together, and when they evaluate to true, the value of the variable allow is set to true. So without further ado, I will save this policy and then try running OPA again with that policy. I have not touched the Python front end or the back end because I don't need to, because my policies are decoupled from my application. All I need to do when my organization policy changed is go back and change my policy as code. So hopefully this is going to run without any errors. And indeed, it ran without any errors. So now our OPA instance runs with the new modified organization policy. That is allow every user to be able to put cars. What I'll do is go back to the front end application. And remember, Misbah was a user who was originally not able to invoke the put API so she can add cars. And if I hit invoke now, and if everything goes well, Misbah is successfully able to add cars, right? So that brings this demonstration to an end. Of course, we will come back to this demonstration throughout the entire length of the webinar and discuss all these things. But what we essentially wanted to do through this demonstration is to provide people that the idea when policy is decoupled from an application that it is associated to, then there's a lot of benefits that we get out of it. And that's what we're going to explore. Back to our keynote presentation. So our demonstration's done. What else do we have in the agenda? Imran explained it, so here's another stab at it. We saw policy as code through an example. There are so many use cases of policy as code. What we wanted to do is take the simplest form of API authorization, so everybody who knows a little bit about HTTP and applications are easily able to understand. And after we understand that, we can translate those concepts to more advanced systems out there, such as Docker, Kubernetes, Jenkins, and so on. And we will explore why you should consider policy as code. Hopefully, if that demonstration did not convince you that you need policy as code, we'll further explore why you need to consider policy as code. And if you have an application or a tool, what is a way, or what are some of the ways in which you can integrate those applications with OPA so you can achieve policy as code? And then towards the very end, we'll provide you some resources, and we'll also take a stab at what it takes to write a policy, such as the one that we just modified. What is the learning and the experience that I personally went through while learning Rego? And those are some things that we want to share in this webinar. So traditionally, policies are written as documents. Now, if you remember that policy, everybody in the car info application should be able to put cars into that system. That's an organization policy change. Traditionally, organizations write those policies in some form of a checklist or an authorization control matrix, such as the ones that are maintained in an Excel file somewhere, and then they get translated into a Word or a PDF document, and then a JIRA ticket's created for them, then a developer is assigned for it, or a development team is assigned, or a development team pulls that request, changes their application code. If it's Python or if it's ASP.NET, then the entire code is recompiled, rebuilt, and the entire application is redeployed. Now, that's essentially what is used to happen traditionally if policies were maintained not as code. However, if you maintain policies as code, look at that example over to your left. It looks neat, well formatted in this case, of course, and it's also pretty understandable. If you look at that first variable there, by default, we're denying everything to false. So it's a great security pattern to get started with, denying all by default and then allowing only what is necessary. So by default, we're denying everything. And if you look at that second method there, we're allowing based on certain conditions. So if you consider policy as code, then you get the benefits of versioning, such as you would get an infrastructure as code, compliance as code, or just any code for that matter. And if you have your policy as code, you can automate your testing of that code and see how much of your policy is covered, and your policy decisions can also be changed over the fly. And then the point that I explained about policies being a readable source of truth, it can also be another added advantage of why you should consider policy as code. But the actual reason for considering policy as code is this is a quote from the project co-creator, the OPA project's co-creator, Torrance Sannel, who mentioned in a talk once that if you have your application's database, messaging platform, and monitoring and logging and orchestration, we have evolved. You know, the process of software development has evolved so much that our database, messaging, monitoring are separate, and treating policy itself as a separate concern is just another step in that process of evolving software development, DevOps, or the cloud infrastructure in general. And if you treat your policies as a separate concern from your applications or tools, then you get greater advantages in terms of maintaining those policies, better control over those policies. Now, here's a screen grab from Open Policy Agent website, where they say the Open Policy Agent tool is a policy-based control for cloud-native environments. It's flexible, meaning that you can use it for any different technology stack. It offers fine-grained control. And if you look at that picture, there's all kinds of modern application stack that you can imagine. There's ingress traffic going through Kubernetes, and there's a CI/CD system service mesh for microservices discovery, and there's an API written in whatever language. And towards the right bottom, there's also another API, and there's a UI front end. They're all written in different languages. And imagine that you have a policy change in your organization's way of working. You'd have to instruct all of these developers and maintainers of these different projects, and they would have to go modify their application code bases and their running instances of different applications, modify them and change them. So if you had your policies separated out of those applications, then you get much more greater control of your organization's policies. And here's a screen grab again from the Open Policy Agents ecosystem. There's many, many logos there. We just saw an example of Open Policy Agent being used in a Python Flask application. If you have Kubernetes for admission control, you can use OPA. And if you have Spring Java for authorization, you can use OPA. And if you have Docker, there's also frameworks such as Conf-Test, tools such as Conf-Test that help you audit your infrastructure as code deployments and so on. So there's many, many possibilities of integrating OPA with your applications. If you do not see your application or your technology stack's logo in here, we'll discuss some techniques towards the end of the webinar, using which you can potentially try to implement OPA in all of these in your specific technology framework. And that's also a challenge. When I got started with OPA, there were these amazing demonstrations of how you can use OPA for Kubernetes admission control, how you can use OPA for API authorization, and many, many use cases. But what I lagged is I couldn't really find any resources where someone taught me how to integrate all of these things together. So, and that's also the reason we named this webinar, how to learn policy as code with OPA without losing your mind. So another interesting thing, if your service or your technology stack is not here in this OPA ecosystem, it doesn't really matter, because OPA as a policy decision engine, it only decides whether you should allow or not. Again, I'm using the word allow or deny to keep things really, really simple, but OPA can return much more complicated JSON responses, which we will look at in a little bit. OPA doesn't care if you're running Kubernetes. OPA doesn't care if you're running Spring or Docker. In fact, OPA does not even know when it makes a policy decision that it is making a policy decision for Kubernetes or Python Flask or SSH or Docker. OPA doesn't really know that. What OPA cares about is it doesn't care what your service is. As long as the input is JSON, OPA can make policy decisions based on the input JSON that it is provided to, and then OPA responds with a JSON output. Now, in our example, we sent JSON input from our Python Flask API to OPA, and then OPA responded with allow is equal to true or false. And that allow was in fact in a JSON format, which is all encapsulated nicely into that API and into the front-end application. So OPA doesn't care whether your service is Kubernetes or whether your service is XYZ, as long as OPA as long as you can send JSON input to OPA, OPA can make policy decisions based on given policy, and then OPA can respond back with a JSON object. In our case, which simply happens to be allow is equal to true or false. So here's the next part of that webinar. All right, I get a message that my connection is unstable. What I'll do is cut my video off. Okay, Imran, I hope you did that for me. Okay, hopefully my audio is still okay and you're able to see my screen fine. If you would like to integrate your applications with OPA for making policy decisions, there's three simple things that are required. Again, this is an oversimplification to introduce you to the various moving parts of what it takes to integrate OPA with your application. But in real world, it can get a little bit complex, but after getting your fundamentals right, and I'm sure you will be able to successfully integrate your applications with OPA. So there's the first step. You have to create an input for OPA. What I mean by that is because OPA takes JSON input, if your application does not in any way have the ability to JSON input, you have to create a certain input for OPA, and we will see how we have created that in the sample Flask application to put things in perspective. And after you've created the input for OPA, the next step is to query OPA, is to send OPA that input and then a policy so that OPA can check that policy, check our input, and then decide whether that request needs to be allowed or denied. So these are three essential things. And if I have to put this in perspective for a Python Flask application, it would pan out in this way. Now, there might be a lot of code on the left, but they're really simple once you get a hang of it. So here's the first part, creating an input for OPA. If you remember the initial policy that we edited, we needed three things. We needed to know what the input method is, which is what we're getting from request.method. And we needed to know what is the HTTP path that was coming from that request. So that's the second one there. And the access token and the ID token that we got from Azure AD are the essential means of checking who the user is and what roles does the user have in a system. So that is the first part where we create a JSON input for OPA. And the second box is where we actually query OPA. When I ran on the command prompt, OPA run -s with a policy, OPA started running, and then it also has exposed the HTTP API. So we're querying OPA from our application through the HTTP API with the JSON input that we've just created. So that's the second step. And the ultimate step is to finally check for the value of allow is either true or either false. In this case, if the value is true, we don't do anything. But if the value is false, we abort that request with a 403. And notice the first line of this code. It has this at dot before request. Now in Python Flask, in Python Flask, app dot before underscore request, any method under it gets called before the actual method gets called. So if we actually call the API to get cars, and before Python actually processes the API, it's going to call this method. And in our case, we're just integrating OPA into that method. Now, to demonstrate this case and to put things a little more in perspective for you, what I have here is, let me exit out of the keynote. Here's the visuals to the code instance, and the screen grab that you saw on the keynote presentation is the exact same code that you see here. What I also have is a local instance of the same application that is running in my local computer, and I will try to demonstrate that as well. So here's a local version of the same app that we saw in the practical DevSecOps labs. So now we're logged in as Alice Cougar. I'll refresh this page just to make sure everything is working. Alice Cougar happens to be a manager on that system. So let's check if Alice is able to get cars. And if I invoke this API, I have sufficient breakpoints in Visual Studio Code just to show you how this all works out. So when I invoke, immediately before calling the actual method, which is get/cars, we hit the before request part of the code. So in before request part of the code, we create this JSON input. And as I mentioned before, if I expand this terminal window here, and if I step through this particular statement, what you see here is the data that we're sending to OPA. Well, we're getting an empty token in this case, so because it's an options request, and please don't worry about it right now, because options request is a pre-flight request, which is there to make sure AJAX requests work. So I will continue this and then show you the next statement here. So here's our next statement, which is the actual request for get cars. So we needed 4 things here. We needed the method, and we needed the path, and we needed the access token, and we needed the ID token. So those are the 4 essential values in the JSON object that we're sending OPA. And after we send this to OPA, let's query that, and let's check whether if it's a successful response. And after that, what we're doing now is assigning the value of response to a variable called allow, because Alice is a manager, and because this is a simple request for getting the cars, everybody should be able to get cars in that system. So if I hover over that value allowed, our policy has returned the value true. So what we're doing now is going ahead with that request and to display the car. So if I go back to our application, Alice Cougar is successfully able to display cars. Now, just to make sure that we all understand this and not missed anything by oversight, I will also try to put cars as Alice Cougar, invoke, and I know by experience that this is the first request with the options HTTP verb. So I'll forward that. And on the second, if you say, we now have the request as put, and the value for the path is a JSON array there with our information cars and cars too. Again, because Alice happens to be a manager in the system, she's gonna, she would have evaluated the policy as true, and if I go back, that response should have succeeded as well. So that's really an example of, if you don't have integrations in your technology stack out of the box for OPA, this is a way that you can create your own requests. It just took me one simple line to gather all that input and put them into a nice JSON object, and one other line to call OPA, and a couple of lines to make a policy decision, which in this case happens to be simply allow or deny. And in Python Flask, we can take advantage of app_before request. I come from an ASP.NET background as well, so there's application filters there which allow you to do some actions before a request is actually called. They're called middleware in different technology frameworks now. So if you don't have OPA middleware for your application, here's a simple way you can write your own OPA middleware to make policy decisions for you. Again, I'd like to reiterate, there's 3 simple things that you need. Number 1, construct input for OPA. And number 2, query OPA. And number 3, check that policy decision. This might widely vary depending on what decisions you want to make. But however, I hope this is going to get you started in your journey of getting started with OPA. So that's there. Now we're done with that. What we're going to do next is identify. Let me get through these slides quickly. So here's an important thing. OPA is a policy decision framework. So OPA makes the policy decision, and it is the job of the service to enforce that policy decision. When I say service here, I mean the Python backend API. Let me switch back to the code again. So here we are in VS Code. So the entire line of code, server.py, happens to be the Python Flask application. So this is Python Flask deciding whether to abort or go forward with that request. What OPA does is makes that policy decision here to allow or not. So we're calling OPA, and OPA tells us whether the value is allowed to be true or false. So after we get that policy decision from OPA, it is the job of the Python Flask framework here to enforce that policy, which in this case happens to be allow or deny. So OPA is a policy decision framework, and it is the job of the service to actually enforce that policy decision. Again, this is the next part of the content today, where I want to give you a little bit of tips in terms of what it takes to write policies in Rego. So there's 3 different ways available for you to write policies in Rego. There's a command line REPL interface called OPA. So you could basically do OPA run, OPA build, OPA test, and so on to even unit test your policy files that are written in Rego. You also have a Visual Studio Code add-on for Rego that helps you evaluate those policies. And there's also an online version of play.openpolicyagent.org provided by the company that created OPA, which is Tira, which is what we will be looking at today. So there is a Visual Studio Code add-on. I'm not going to demonstrate that because I have a live debugging session going on right now. I don't want to I don't want to interrupt that. So we will go and experience play.openpolicyagent. And I'll get started by explaining what it took for me to write the policy that is currently integrated with the Python Flask application. So here's the policy that is written in the Python Flask application. But before I wrote that policy, what I did is went to the Rego playground and started as anybody else. So let me refresh this page. I don't want to save. So
Maran, we do have a couple of questions now. Would you like to take them now or at the end of the session?
Well, we're almost at the end of this session, Imran. So I estimate about anywhere between 5 to 5 minutes. Hey, but let's take some questions right now. I think that's a good idea. Let's take some questions.
Sure. So here's a question. Question number 1 is, the policy looks like it's a API gateway or a WAF rule. So what is it really? Is that question?
All right. Okay. So the policy here, in this case, seems to allow or deny, right? Which might sound like a WAF rule because we're essentially allowing and denying. But Rego as a policy framework and in general policy as code is capable of handling much more things, such as whether you want to admit somebody to Kubernetes in the form of admission control or not. If you have a policy such as, let's take a generic example. Imagine that you have support staff working on supporting your system, and they would like SSH access to a certain machine. If you provide all your support staff to all your production environment, then that could sound like a huge security hole. But if you have an organization policy that says the support staff should only have access to the machines that they're assigned in a particular ticket, if we could write that as a policy, then it would be a much more restrictive way of doing security control. And that is completely possible in OPA. This example might sound like it's a WAF rule, but it's definitely not. And again, this is an oversimplified demonstration, but OPA is much more capable of doing a lot other things. And hopefully that example offers some perspective there.
Okay, so the next question is, the the policy as code sounds great, but how do you secure the policy as code itself to take security to the next level?
All right, that's a great question, which also reminds me of something that when we talk about DevSecOps, we often talk about securing the code that comes out of our pipelines, but who's going to secure the pipelines and the CI/CD systems themselves? Well, it's a great question. When it comes to securing policies, you can normally have your access control, and because policies can be versioned, you can enforce your access control on your version control systems. Rego actually supports bundling these policies together. You can actually pull policies dynamically through bundle APIs that are available in Rego, and those APIs can be access controlled as well, right? And the other way, if you look at the OPA deployment itself, when we downloaded the OPA executable, it's as little as 20 megabytes right now. OPA executable can run independently as an executable. There's also an alternative version of running OPA as a sidecar, where OPA runs very parallel to your application. If your application exits, OPA exits as well. So that's the relationship of the OPA being a sidecar of an application. So in that case, you essentially have to secure your application infrastructure where OPA is running. And there's a third way, which is actually running OPA as, because OPA is built, because OPA and Rego are built in Go, you can also load OPA as a dynamic Go module if you're using Go-based technology stack. But the answer to that question essentially boils down to where you're storing your policies, and are they version controlled? Do you have good RBAC? And thinking of eating your own dog food, you can actually have OPA policies to secure your version control system where you actually put your policies. So I hope that answers that question there.
Okay, a follow-up question on that is, do you is it similar to this role? It's pretty similar to AWS role.
Well, AWS role has a certain purpose, and it is limited to the AWS cloud and the infrastructure themselves. But OPA is a general purpose policy framework. You can use it with AWS for identity and access management or controlling access to AWS. You can also access OPA for a lot of other purposes, like discussed before.
Okay, so I gotta know, I'm not sure how to interpret that, but I'll take it this way. Okay, yeah, okay. I mean to say, how can we prevent changes through access control? Is it? Like, how do we secure this authorization configuration?
All right, so if the question is about securing the authorization configuration, which is written as a policy here, then that boils down to securing your policy as code itself. Just as you would secure any code, you could apply the same principles to your Rego files as well. But if the question is something else, then we can, of course, talk about it.
Okay, sounds good. I think that's the question. Yeah, use your role-based access controls on your version control systems, and I think how you would deploy it would be the similar.
Yeah, but if there's a follow-up question, we could definitely take them towards the end when we open up the microphones, I guess.
Okay, sounds good.
Another question, and then I'll continue the demo and then open up for questions entirely.
Okay. Sure. So the question is, I think policy as code would be a good option to achieve compliance and regulatory requirements. Otherwise, this can be an overhead, consider if the policy as code solution isn't available. So yeah. So he's saying, if I have to paraphrase that question, like, would it be overhead compared to what we already have at the moment?
I certainly think it will not be an overhead. But I think the question behind that question, if I can interpret that right with my skills, with my question interpretation skills, OPA is a new change, right? It's a new paradigm to write policy, to write policies. And if you want to do traditionally the way you're doing your access control or admission control or whatever decisions, then it's perfectly fine. Getting into this new stack takes some effort and takes some new mindset to actually implement it. And in some cases, it might be even a large months of projects work together. So that really depends, but not as an overhead if you compare the advantages of what you get from decoupling your policy decisions from your technology stack. Well, think about if you have to make an application change, you have a service written in Python, you have a payment service that's written in .NET, and another service that is deployed as a microservice somewhere else. If you have to implement policy decisions in all of these places, and if that all can be done in one language, Rego, then I guess there's lots of advantages there compared to the overhead. Of course, there's a starting effort, but then the payoffs are really well. So Imran, what I'll do now is continue back to the demonstrations that I got going on.
Sure.
And in 5 to 6 minutes, we'll open up for questions.
Sounds good. Thank
Okay,
you.
so when I started writing my first Rego policy, I started with VS Code, and it was good enough to get started with. But the next thing that I wanted to do is head over to Open Policy Agent Play, and there's a default policy. And if you pull down this example section, there's many examples here. So there's examples for role-based access control. So here we're allowing somebody when he has an administrator role, right? And when I had to process JOT tokens, so I essentially took this particular policy here, where we're using an inbuilt component or an inbuilt method available in Rego for decoding a JOT token. So I started off with this policy, and then I ended up finally writing the Rego policy that we actually demonstrated with the Python Flask application, which is here. So if you see the examples of how to get that bearer token and how to get the claims from that bearer token, and all of these are brought down from the example from the Rego playground themselves. And if you remember the VS Code debugging session, we essentially had 4 variables. So I stuffed those 4 variables here in the form of a JSON object in the input because because OPA understands JSON. And then what I do is write policy decisions here. So the access token normally is a bearer token with JOT values inside it. So what I'm doing is as long as access token starts with a bearer space, then I extract the value of the JOT token there. And after I extracted the value of the JOT token, what I do is decode that JOT token into a variable called payload. Now there's 2 empty variable declarations there because JOT token has 3 parts. There's a metadata, there's the payload, and there's a signature verification. I'm only interested in payload, but in real world, you would actually be validating, you would actually be taking that signature value from that JOT token and verifying it just to make sure that it satisfies your authenticity and integrity requirements. So in this case, I'm just only interested in payload for demonstration purposes. And what I do, the payload essentially, if you have to print it as a JSON object, gets nicely decoded into the output that you see on the screen. And as you can see, there's 2 different roles for this particular person called Alice Cougar. Now she has a manager role and a car admin role. So the next job is to understand the JOT token and extract the value for the username. So that's something that is done here. So I take the ID token claims and then I get the name and then I store it in a variable called user. And then I process the roles, take that as an entire JSON array, and assign it to the variable roles here. So once I'm done with that, all the way to the very end of that policy, I have these 3 different helper methods. They don't do anything in the policy decision themselves, but they help in aiding that policy decision. So I check in the roles array if there's a value called manager, if there's a value called admin, and based on that, I'm making my policy decision. And as we have experienced it in the demonstration before, if I have to write a new policy for allowing the value input dot method is equal to put, and the value of input dot path is equal to cars, comma car underscore ID. And as long as the user is authenticated, I want to allow this put request. So this is exactly what we wrote in our initial demonstration, right? And if I don't have this Rego code here, let me cut that out here, and I will try it with this evaluation. And I see that the value of allowed is set to true because we're sending a GET request for cars, and everybody should be able to get that GET request now. If I set the value to put and provide a token for MISPA, the user MISPA, who just happens to be everyone in that system, then that request will be allowed as well. So here's another interesting thing. How about unit testing, or even making sure, does this input cover all the lines of your policy? So you can check that coverage option there. And this option is also available in the VS Code plugin. So if you evaluate that policy, the statements in green are the statements that are covered during this evaluation process, and the ones in red are the ones that are not covered during this evaluation process. So hopefully that offers some perspective to getting started with Rego language. But in reality, there's lots of resources that we have accumulated in this GitHub project, Awesome Policy as Code. There's blogs, videos, tutorials, and other resources. Feel free to check them out. There's also a free course from Stira themselves where they teach OPA and Rego, right? Well, if you want to know more about the constructs of the Rego language, then I highly recommend this course. Hopefully, after having seen the integration points, if you take the course, things will start to make sense. So let's take questions now and see where that takes us. So that's pretty much what we had to present to you today about OPA. Again, we wanted to keep things really, really simple, and hopefully we were successful in that attempt to most of you.
Okay, so the question I have is it the best way to implement such a role-based access control in such files, basically in files? I think maintenance will be difficult in a microservice world where everything is distributed.
Right, so imagine that you have 100 microservices running across different places. If there are 100 instances of the same microservice, then you're just going to need one policy file. But if all those 100 microservices are completely different microservices, they're going to make different authorization decisions. So they are going to need different policy files, and you can bundle them together if you like. However, if you look at the other way of making authorization decisions, then you would actually be hard coding, for the lack of a better word. You'd be hard coding your policy decisions into those microservices code, wherein controlling those authorization decisions becomes difficult. You might have to recompile your applications and so on. But if you manage them as a separate entity themselves, then you of course have better visibility in terms of what your access control decisions are in the first place. So that's the way, that's the perspective I can offer there. And that's also why I think OPA can really be helpful in that scenario as a policy as code solution.
Yeah, and if I could give another analogy, if you guys have used HashiCorp Vault, it acts as a single service where you store secrets, be it APIs, passwords, and whatnot. And that's the single service which is consumed by everyone else to either pull, push, or kind of secret, consume secrets in a way. Similarly, policy as code allows OPA allows you to have one single service which makes your access control, if you have to say that word, or allow, deny actions, or any kind of a policy, an organization policy. You take that policy, compliance policy, convert it into code, and it is now enforceable across the organization rather than just one application, one instance, and whatnot. Yeah, I think that's. And then we have one more question. It's called. Okay, so do we have any built-in templates, common built-in templates for providers like Terraform, Kubernetes, which we can just use and get started quickly?
Yes, definitely. There's tons of templates, and where I would like to refer to the person that asked that question is to the OPA ecosystem page. If you click on these logos, you'd be redirected to the GitHub page of those profiles where you would have policies that you can link. With respect to Terraform in particular, there is a project called conf-test that uses OPA and that allows you to analyze your Terraform files to make sure that certain things are not allowed in those Terraform files. Again, all of these resources are tagged to the awesome Policy as Code project as well.
Great, thank you so much, Maran there. And if you have any questions around this topic, please do reach out to Maran or on his email address and on Twitter profiles. I'll share those in the chat and also in the email if you're interested. And if you need to have access to the lab, which Maran showed you, please send us an email. I will be happy to provide you the access there as well. And with that, thank you so much for being part of the session. We are planning few like following up sessions with this OPA topic and a bunch of other DevSecOps topics. So please do consider following us on Twitter and also on LinkedIn so we can announce these things and you get to know these things when we do announce them on our LinkedIn page if you haven't already done so. Okay, thank you so much and have a good day. And yes, we will share this presentation via email to anyone who has registered for this session. If you haven't already, please do go ahead and register or send me your email address and I will make sure that I will forward it to you. Great. Thank you so much and have a good day. Bye-bye.